Hi guys, so in this video we're going to look at what's called the fundamental principle of counting. We've done this before in second year, and essentially it's this definition here. So suppose to obtain an outcome for an experiment we have to perform one stage and another stage, and the key word here guys is and. As soon as you see the keyword and, it means multiply. So it says suppose that the number of outcomes for the first stage is x and the number of outcomes for the second stage is y, and the total number of outcomes for the experiment is x multiplied by y. So again, look, it says here, if you see and in probability counting, it means multiply. Now this can be extended into if there were three stages, then it can be extended that x times y times z. So let's have a look at an example. So it says in a restaurant, Susan wants to pick one starter from 5 possible starters, one main course from 12 possible main courses, and a dessert from 6 possible desserts. In how many ways can she pick her meal? Well, I like to use what's called the box method here, guys. So I'm going to write starter. Okay, there's the starter. We have main, and then we have the dessert. I just draw a box. Okay, and it's very straightforward. It says one starter from 5 possible, one main course. So that you can see there's an implicit and here. So what we're going to do is going to be multiplying these together to get the answer. So what we have is 5 possible starters. That means she has 5 choices for the starter. There are 12 possible main courses, so 12. So it gives her 5 times 12. And then there are 6 possible desserts, which means times 6. And if we multiply them together, 5 times 12 times 6 is equal to 360. You can either do that in your head or use your calculator. Okay, the second fundamental principle of counting is as follows. If an experiment can be performed in one way or in another way, but not both, then what we do is we add them. Okay, so essentially where we saw in the last slide, if we saw and, it means that we multiply. If we see the keyword or, it means that we add them this time. Okay, so that's important. Let's have a look at example 2 here. So what we have is a security code for the door consists of 2 letters followed by 2 digits. So we've been given a couple of examples here. So BX04 and GG55. So you can see here that what we can do is we can repeat the letters or we can repeat the digits. That's important because sometimes we're not allowed to. So the first part asks, as Mary says to us, Mary chooses her own code. If there are no restrictions, i.e. that we can choose anything that we want as long as the first 2 are letters and the first 2 are digits, how many different ways can she form her code? So again, what we're going to do is we're going to write down the box method here. So we know we're going to have 4, 1, 2, 3, 4, because she needs to have 2 letters and 2 numbers. And what we are doing, remember, all the boxes are telling us are how many possible answers we can have, how many possible letters or possible digits in this particular one. So we're going to have a look at the first one. And the first one here has to be, so this one here has to be a letter. And we can choose any letter we like, as long as it's obviously a letter from the alphabet. And that means that we have 26 choices for the first letter of the code. Now if we look at the second one again has to be a letter. And there's no restrictions, which means that if I want to, I can choose the same letter as was in the first, as the first letter here, which means that I still have 26 choices to choose from, i.e. any letter from A to Z. Now let's have a look at the next part of my possible code, which has to be a number. Now that means I can choose any digit between 0 and 9. So 0 to 9, that means that I have 10 choices because I have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. So you have to be careful and just make sure you don't forget the 0, which means that for this particular one I now have 10 choices. Again, if I have a look at the last digit, the last part of the code there, you can see here I'm allowed to repeat numbers because there is no restrictions, which means that again I have a choice of all the digits from 0 to 9, which means I have 10 choices, which means I can have 10 different ones in order to do this. I then multiply all of these together And if I do that, I get 600 just from my calculator. Now, the reason I'm multiplying these is, if you think about it, I can say this in a different way. So what I'm doing is I'm saying I want a letter and another letter and a digit and a digit. Okay, so let's have a look at part two. Part two is a little bit more interesting because we now have some restrictions on what we can choose for the particular letters and digits. If you have a look there, it says Joe wants his code to contain the letter J. So J has to be in it, and we're not allowed to repeat any letters or digits. So let's see how many ways we can do this. Right, let's have a look. So the first thing we do again is we draw our 4 boxes. And this time, hopefully you can see that if it's got to have the letter J in it, it's either going to be in the first one or the second one. So again, notice that keyword or means that we're going to add. So I'm going to draw 2 of these. This time I'm going to put the J here. Okay, so there's 2 ways we can have this. We can either have the J as the first letter, or we can have J as the second letter. It can't be the 3rd or 4th positions, because the 3rd and 4th positions have to be numbers. Okay, so let's have a look at the first one, where J is in the first box. Now remember what the box means. The box is the number of particular choices that we have. And this box here, it has to be a J. So we don't really have any choice. We've only got one choice, and that choice is the J. So we have to have the J. There's only one J, so therefore there's only one way we can fill that box. Now we go to the second box. We can have any other letter apart from J, because we are not allowed to have a repeated letter. So instead of having 26 choices like we did in the previous example, we now only have 25 for this particular box. We then go on to the numbers, and we can have any number that we wish for this one. So again, just as before, this is going to be 10 choices, 0 to 9. But if we look at the definition, or we look at the question, it says no repeated letters or digits, which means that I can no longer pick from 10 because I've already picked one. I now can only pick from 9 left. So if you think about it, suppose I chose 2 for this particular box. That means that 2 is no longer available for this box, which now means I don't have 10 choices, I only have 9. So now let's look at the second set of boxes where J has to be in the second position. And that's the one we deal with first again. So you can see here J's in the second position. But this is where our constraint is, and we always try and work with our constraints first. So again, we have no choice about what letter this box is. It's a J, so we only have one choice to stick in this box. Let's go to the first box now, and because this second box is a J, that means again we can't choose J for this first box. So instead of having 26 letters of the alphabet to choose from, I only now have 25. Once I've done that, I need to go and look at the digits again, and hopefully you can see it's the same as before. For my first box, I have a choice of 10, and whatever box I use in here, I cannot use in here, which means I now have a choice of 9 for this second box. So this is going to be 10, and this is going to be 9. Now all we do then is we work out those particular values, and if we do that, you find if we multiply all these together, this will be 2250, and this will also be 2250 when you multiply them together, because it's the same thing. And you can see here it says how many ways you can form the code. So it's either this way at the top or this way on the bottom, which means the total number of ways that we can do it, given the restrictions that we've been given, is to add the 2250 from the top to the 2250 on the bottom, which is 500 ways according to the restrictions. Okay, I thought I'd do a few more questions because some people find this a little bit more difficult than others. So we're going to look at question 7 and question 11 from the textbook. So question 7 says, how many 4-digit numbers greater than 4,000 can be made from the digits 1, 2, 3, 4 and 5 if no digits may be used more than once, and if repetitions are allowed. So first we do, we're going to get a 4 digit, 2, 3, and 4. So we'll do part I first. And what we have here is you've got to think, how many 4 digits greater than 4,000? Well, if it's greater than 4,000, what we can say is that first one is restricted. It has to be a 4 or a 5. That means we have a choice of only 2 for this first box. We can only have 2 possible answers. Now it says if no digit may be used more than once, which means that we are not allowed to repeat. This means now that I don't have a choice of 5 for the second box. I only have a choice of 4 because I've used either the 4 or the 5 in box 1. So I now have a choice of 4 for the second box. And I'm going to choose one of those 4 numbers in the second box, which means I now have a choice of 3 in the third box. And likewise, for the final box, I'll have chosen one of the 3 remaining in the third one, which means I now have 2 left that I can choose for the last box. I'm then going to multiply them together, and I'm going to get 2 times 4, 8, 8 times 3 is 24, 24 times 2 is 48. So there's 48 different ways that I can write or get a number greater than 4,000 from the digits 1, 2, 3, 4 and 5. Right, let's have a look at part 2. So part 2 again, I've got exactly the same sort of problem, the fact it's a 4-digit number greater than 4,000, but this time I'm allowed repetition, which means I can reuse numbers. So it's going to set up exactly the same way. It has to be a 4 or 5 if it's greater than 4,000 for my first digit, which means again I have 2. Only 2 ways of doing that. But now what I have is the fact I can use any number. Repetitions are allowed, which means I have a choice of any of the 5 numbers, 1, 2, 3, 4, 5, and again 1, 2, 3, 4, 5, and again 1, 2, 3, 4, 5. So what I have there is 5 times 5, 25 times 5, 1 to 5. That turns out to be 250 different ways. Let's have a look at question 11 now. And it's a code number, again, which is a whole number between 10 and 1,000. How many 2 digits have different digits? So different digits, that's important. So 2, that's just 2 boxes. And it says between 10 and 1,000. Now it's really important you read the question here, because that 10 means that we cannot have 0 as our first digit. So it means we can't have 0 here. We can have a 1, a 2, we can go all the way up to 9 to get to 99 if we wish. Well, it'll be 98 because we have to do 2 different digits. But we can't have 0 as our first digit. So that means we only have a choice of 9 because we can't have that 0. It says we can't have the same digit, i.e. they have to be different digits, both this one and this one. So that means that I now need to, for example, if I've chosen the digit 1 here, I can't choose the digit 1 for this one here. However, I can choose 0. So that means that I still have 9 choices for this particular one, and that gives me 81 different codes that I could have with 2 digits. Let's have a look at the second one. Okay, the second one, again, it's a 3-digit code this time. Okay, times in for us. And again, it has to be a whole number between 10 and 1,000. So that means that this first digit, again, cannot be 0. It cannot be 0. Which, just like before, when this couldn't be 0, means that we have 9 choices in order for that. Now, the 0, just like before, comes back into play. So, even though, suppose again, I chose 1, here, I know I can't have the 1 here, but the 0 comes back into play, which means I now still have 9 choices for that second digit. Now the third digit, I have 8 choices because I've already picked one number here. I picked another number here, which means I only have 8 numbers left that I can choose from. And now I just work that out. And 9 times 9 is 81, and 81 times 8 is 648. And we're done.